All right, our last method of solving systems of linear equations is called the addition method. It is sometimes called the elimination method. So those terms can be used interchangeably, but our goal here is to possibly manipulate our equations so that one of the variables has a coefficient that's positive and the same coefficient that's negative in the other equation, so that if we add those together, then we're ending up with 0 for one of those variables, and that eliminates one of the variables, and so that's why we call it either the addition method or the elimination method. And we can just keep in mind that anything we do to an equation, as long as we do the exact same thing to every single term in that equation, we're not changing that equation at all. So if I want to take an equation and multiply it by 7, or multiply it by 2, or add 5 to every term, or whatever we wanted to do, we can do that as long as we do the exact same thing to every single term in that equation. We're not changing it at all. So we're just going to manipulate these equations just a little bit in order to make that positive and negative coefficient on one of the variables be the same, so that one of them adds up to be 0. So here's the first example is pretty easy. I didn't make any thing that we needed to change, just so you can see how we add both of these two equations together. So notice here on these two equations, x plus y is equal to 5 and x minus y is equal to 9, that we have a positive y and we have a negative y. So those coefficients are positive 1 and negative 1. So if I add them together, I'm going to end up with 0. So let's just go ahead and add the two equations together. So if we have x plus x, remember we can only add like terms, and the variable part stays the same. It's just however many that we have. So in this case, we're going to have 2x. And remember, when we add those, that is not x squared. That becomes x squared when they are multiplied together, not when they are added. And then 5 plus 9 is 14. So see how we've, just by adding these two equations, that we've eliminated one of those variables. And that way just leaves us to solve for the one variable that's left. So in this case, x is going to be equal to 7. Well, now that we know what x is equal to, we can easily just go back and say, well, let me take one of these original equations. I'll put the 7 in for x, since we've already solved for it, and then we can go solve for the y variable. So if we subtract that 7 from both sides, we're going to get y is equal to negative 2. All right, so remember, our solutions are always ordered pairs. And ordered pairs always start with the x value. So in this case, that would be a 7. The y value is a negative 2. So that is the answer, that ordered pair that satisfies both of those systems. And remember, you can go put those solutions back into your both of your original equations, and make sure that they make them both true in order to check your answers. Okay, let's try another example here. So we have 4x minus y is equal to 22. Then we have 3x plus 4y is equal to 26. All right, well, we do not have two terms that are positive and negative with the same coefficients. So we are going to manipulate one or either both of these equations as we want to create a positive and negative with the same number coefficients. Well, let's just look at both of our equations. We've got in front of our x's, we have one that has a 4 and one that has a 3. Okay, so then on our y's, we have a negative 1 and a positive 4. Well, probably the easiest thing there to work with would be those y's, because we know we already have that negative y, but now I can multiply that whole equation by 4 and make that become a negative 4y, so then that would cancel out with that positive 4y that's in the second equation. So I'm going to take the first equation and multiply every term by 4 and create a new equation over here. So 4 times the 4x is 16x. 4 times the y gives me 4y. And 4 times 22 is 88. So just remember, I have to do it to every single term so that I'm not changing that equation. So all I'm going to do here is rewrite the second term so that they're lined up and I'm ready to add them together. Okay, so we have 16x plus 3x gives me 19x. Now these 4's, I have a negative 4y and a positive 4y, so that just makes 0, which was our goal. Then we have 88 plus 26, which is 114. Then we divide both sides by 19, and we get x is equal to 6. All right, well, now that we know what x is, it's really easy for us to go and substitute that back into one of our original equations and solve for the y variable. So I can take either one of those equations, it doesn't matter which one, and I'm just going to substitute this x in for the x in that equation and go solve. So 3 times x, which we now know is 6, plus 4y is equal to 26. So 6 times 3 is 18, plus 4y is 26. So we'll subtract our 18 from both sides of our equation, and we're ending up with 4y is equal to 8. We divide both sides by 4, then y is 2. So now we know the ordered pair that satisfies this system of equations is 6, 2. Remember, your x value always goes first when you write that ordered pair. And you can go substitute that back into both of the original equations and make sure that what you've got is true. Okay, next one. We have 4x plus 5y is equal to 3. And we have 2x minus 3y is equal to 7. Well, let's think about these equations, and we need to manipulate one or both of them in order to have those opposite coefficients be the same. All right, so let's see. We have a 4x and a 2x and a 5y and a negative 3y. Well, if I just multiply this second equation by a negative 2, that would give me a negative 4x for that second equation. And that would be the easiest thing to do. So let's rewrite the first one. We have 4x plus 5y is equal to 3. Then our new second equation, every term multiplied by a negative 2. So remember, this one's by negative 2, this one's times negative 2, and this term is by negative 2. So watch those signs, because 2x times negative 2 is negative 4x. Negative 3y times negative 2 makes positive 6y, and then 7 times negative 2 makes a negative 14. And now we're ready to add these two equations together and eliminate one of these variables. So notice, this becomes 0 when I have the positive 4x plus a negative 4x. 5y plus 6y is 11y. And then 3 plus a negative 14 is negative 11. So we'll divide both sides by 11, and that gives us y is negative 1. All right, so now that we know what y is, we can go back up to either one of our equations. And let's see, I might just take the first one. It doesn't matter which one you choose. So 4x plus 5 times y, which is negative 1, is equal to 3. And all we did was take this and stick it in for the y. So 4x minus 5 is equal to 3. So let's add 5 to both sides. So 4x is equal to 8. Divide both sides by 4. So x is 2. So the ordered pair that satisfies this system of equations is 2, negative 1. Okay, I realized I gave you one here that had some horrible fractions in it, so I changed it to make it a little bit easier because I wouldn't give you one like that on a test. So, all right, so we have 5x is equal to 4y minus 8, and 3x plus 7y is equal to 14. Well, first off, this equation needs to be in standard form, right? Remember, we talked about it has to be in ax plus by is equal to c format. So all we're really going to do here is take this 4y and move it over to the other side, okay? So that equation, whoops, I don't want that color. That equation is going to be 5x minus 4y is equal to negative 8. And all we did was move that 4y over to put it in standard form. The second equation is going to be, I'll leave it the same, and then we'll figure out what to do now that they're lined up pretty. Okay, well, we have a 5x and a 3x, and we have a negative 4y and a 7y. Well, we can either make both of our x's be, that common multiple would be 15, or we can make both of our y's be, that common multiple would be 28. So it doesn't matter which one we choose. We can do either one. So I might just work with the x's because then that just gives me a little bit lower numbers. So no rhyme or reason, just whichever one is easier. So I'm going to multiply this first one by 3 to make it 15. All right? And all you're doing is trying to find out what's that common multiple between those two x values, the 5 and the 3. And so if we were to list those out, which I think we did some of that at the very beginning of the semester, we could list out the multiples of 5, 10, 15, 20. We list out the multiples of 3, 6, 9, 12, 15, 18. Well, the lowest one that they're going to have in common is 15, and so that's what we want to be able to make both of these equations be, or both of those x values be 15. All right, so we're multiplying every term by 3 in the first equation. So 5x times 3 is 15x. 5x times the negative 4y makes negative 12y, and 3 times the negative 8 makes negative 24. Okay, so now we're going to take the second equation and we will need to make that one a 15, but we need to make it a negative 15. So we're going to take the second equation and multiply it by a negative 5, because that's what's going to make that 3 become a negative 15, so that when I add them together, I'm going to get 0. Okay? So the 3x times negative 5 makes negative 15x. The 7 times negative 5 makes negative 35y. And then the 14 times negative 5 gives us negative 70. Okay, so now we're ready to add these two equations together, and notice that we have opposite coefficients there for our x values, so those become 0. So positive 15x minus 15x. Actually, guys, I know that that's getting a little crowded over there, so I'm just going to rewrite these two equations over here so that you see them better. So negative 15x minus 35y is equal to negative 70. Okay, that's a little bit better. Okay, so notice now when we add these together, that's 0. And then we have a negative 12 and a negative 35. So that gives us negative 47y's. And that's equal to the negative 24 plus a negative 70 is negative 94. Okay, so divide by the negative 47 on both sides to try to get that y all by itself. And we're saying negative 94 divided by negative 47 ends up being a positive 2. So remember, negative divided by negative makes a positive. And then always remember, you can use your calculator. Okay, so we know that y is 2. So we can go back and take either one of these equations. It doesn't matter which one. And it doesn't matter where I start. But I can just start with this one. 3x plus 7y is 14. Remember, we're not doing this one. Okay. And we're going to stick the 2 in for the y and solve for the x. Divide both sides by 3. 0 divided by 3 is 0. And if you forget that rule, 0 can be on top, but that's 0, but 0 cannot be on bottom. That would make it undefined. And also, if you put those in your calculator, if you ever doubt those, your calculator will either give you an error for that, or it will tell you that the answer is 0. So if you remember that division by 0 rule. So the ordered pair that satisfies that system of equations is 0, 2. Okay, so I think we have a couple more examples. If you guys want to stop your video, try to do it on your own, then feel free to. See if you can come up with what numbers you need to multiply each one by. Okay. So I might just take this first one and multiply it by a negative 3. To make that a positive 3x, a negative 3x, and then a positive 3x on the bottom. So let's see, that gives us negative 3x minus 6y is equal to negative 12. Then I'll recopy this one, and I get 3x plus 6y is equal to 13. So now we're ready to add those equations together. Well, look what happens here. If I have that negative 3x and a positive 3x, that becomes 0. But all my 6's, my y's also are both 6's, positive and negative, so that's also 0. So everything on this side of the equation is 0. 0 is equal to negative 12 plus 13, 1. Well, 0 is never going to equal 1, so that is not true. So there is no solution to this. And again, what makes those no solutions is if they are what kind of lines? If you said parallel, you are getting smart. Be so proud of yourself, okay? So the next one, let's just see what happens here. We're going to say x minus 5y is equal to 7. And we have 3x minus 15y is equal to 21. Okay. Well, you take a look at that for a second and see which equation we want to manipulate. Looks like we could just multiply this top one by a positive 3. And remember, you don't have to always manipulate for your x values. You can also manipulate for your y values. It doesn't matter. So if I multiply every term in this top equation by a 3, that gives me 3x. Oh, I need a negative 3, don't I? Negative 3. Okay, so that's going to give me, negative 3 times x is negative 3x. Then negative 3 times the negative 5 is positive 15y, and that's going to be 7 times negative 3, negative 21. All right, let's move our second equation over. And again, notice we are coming up with the same variables in front of our x and y's. So again, we have 0 here, we have 0 here, but we also come up with 0 here. So this equation ends up being 0 is equal to 0. Well, that is a true statement. 0 is 0. So that means they are probably going to be the same line, and well, they are the same line, and they have an infinite number of solutions, because we ended up with a true statement. If we end up with a false statement, remember, it's no solution. We end up with a true statement, it's going to be an infinite number of solutions. Okay, good luck on that homework.